Alright, so in this problem, I have x to the power of x is equal to x to the power of 2. So I want to find the value of x here. So for my solution, I'm going to first start by rewriting my equation. So x to the power of x is equal to x to the power of 2. And now I'm going to divide both sides by x to the power of 2. So if I divide both sides by x to the power of 2, I get x to the power of x over x to the power of 2 is equal to x to the power of 2 over x to the power of 2. And x over x to the power of 2 over x to the power of 2, these two cancel out, and I get 1. So I get x to the power of x over x to the power of 2 is equal to 1. Now, if I have something in the form a to the power of m over a to the power of n, this is the same thing as a to the power of m minus n. So x to the power of x over x to the power of 2, that's the same thing as x to the power of x minus 2, which is equal to 1. Now, I'm going to take the natural log or ln on both sides. So I get ln x to the power of x minus 2 is equal to ln 1. So if I have something in the form ln a to the power of b, I can move this exponent and b to the front. So it's going to equal b times ln a. So in this case, I have ln x to the power of x minus 2, and I can move this to the front. So I get x minus 2 times ln x is equal to ln 1. Now I can distribute the ln x, so I get x times ln x minus 2 times ln x is equal to ln 1. And ln 1, that's equal to 0. ln 1 equals 0. So now I get x times ln x minus 2 times ln x is equal to 0. Now, I'm going to go back and factor out ln x. So I get ln x times x minus 2 is equal to 0. And now I get two equations. I get ln x is equal to 0, and I also get x minus 2 is equal to 0. So for ln x equals 0, we already know that ln of 1 is 0, right? So x equals 1. That's one solution of x. And for x minus 2 equals 0, that's simple. All we have to do is add 2 on both sides. And I get x is equal to 2. So x equals 1 and x equals 2 is my solutions. Now, going back to the original equation, we have x to the power of x equals x to the power of 2. So to check, I'm going to first start by plugging in x equals 1. So if I plug in x equals 1, I get 1 to the power of 1 is equal to 1 to the power of 2. 1 to the power of 1 is 1, and 1 to the power of 2 is also 1. So this is right. Now if I plug in x for 2, I get 2 to the power of 2 is equal to 2 to the power of 2. And 2 to the power of 2 is 4, 2 to the power of 2 is 4, so this is right as well, meaning my two solutions are right. Alright, so in this problem, I have 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. So I want to find the value of this. So for my solution, I'm going to rewrite my equation, my problem over here. So 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11 plus 8 to the power of 11. Now, notice how all of these terms here are the same. So I have all the same terms adding with each other. And if I have something in the form a to the power of b plus a to the power of b plus a to the power of b plus a to the power of b, I can simply just factor out a to the power of b from here. So I get a to the power of b times, well, a to the power of b divided by itself is 1. So I get a to the power of b times 1 plus 1 plus 1 plus 1. So in this case, I have a to the power of 11 plus itself 4 times. So I can factor out a to the power of 11, and I get a to the power of 11 times 1 plus 1 plus 1 plus 1. And now 1 plus 1 plus 1 plus 1 is equal to 4. So I get a to the power of 11 times 4. Now from here, a to the power of 11, I can rewrite this as 2 to the power of 3. All I did was rewrote 8 as 2 to the power of 3. And now 4, I can also rewrite this as a power of 2. 4 is the same thing as 2 squared. From here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 3 to the power of 11, that's going to equal 2 to the power of 3 times 11, which is equal to 2 to the power of 33, because 3 times 11 is 33. So I get 2 to the power of 3 to the power of 11, which is equal to 2 to the power of 33. So now I have 2 to the power of 33 times 2 squared. Now, the last part is fairly easy step. Because both of these bases are the same, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So over here, I have 2 to the power of 33 times 2 squared. I can think of a as 2, m as 33, and n as 2. So I can rewrite this as 2 to the power of 33 plus 2, which is equal to 2 to the power of 35. So this is my final answer, and I actually can't simplify this anymore because 2 to the power of 35 is a crazy big number. So this is my final answer. And also, the only way that this solving process could have been faster is in my first step over here. I took a whole 3 steps to rewrite a to the power of 11 plus itself 4 times as a to the power of 11 times 4, when I could have just saw that when it's the same term adding by itself x amount of times, it's just that term times x. So that's a faster way.